The chi-square test is probably the most commonly used non-parametric test. In non-parametric test, we do not assume that data are normally distributed. Therefore, differently from the parametric tests, we don't need to check the normality of the data before we perform the chi-square test. The chi-square test is used when we want to compare categorical or nominal data. Let's consider an example. Assume that you have a pack of goraebab snack, and in a pack there are 9 different shapes of sea animals. Theoretically, each figure should be contained in an equal number. So a group of students tried to count the frequency of each figure. But it turned out that each figure had a different quantity. For example, there were 15 sharks, whereas only 10 crabs. Can we still say the figures are equally contained or not? If not, perhaps the company should fix their machine. Just observing the ratio of 15 to 16 to 15, it is not easy to conclude whether this ratio almost resembles the ratio of 1 to 1 to 1 to 1. Of course, it is also not easy to conclude whether this ratio is different from this ratio. However, once you know the chi-square test, you have much more clear idea. Then let's consider 2 different examples. The first question is whether we have more female students in this classroom. We have 13 females. Number 13 is larger than 8. 13 is even closer to 16 than 8. 16 is the double of 8. So can we even say that we have twice more female students than male students? If we are interested in examining whether males and females are in equal number, the expected ratio between male and females should be, yes, 1 to 1. If we are interested in examining whether females are twofolds or twice more than males, the expected ratio between male and female should be, yes, 1 to 2. So in this case, we have only one variable. And this single variable has 2 levels, which are male and female. Depending on our assumption, we can have a different expected ratio with regard to this one single variable. Now let's consider another example. Based on the actual data in fall 2014, we have a total number of 197 students enrolled in the Department of Industrial Design of KAIST. Do males outnumber females because 100 is greater than 97? Or is attendance dependent on the degree program? Regarding the first question, we can perform 4 different small questions. The ratios of males and females within each group, within each program, and then the total. However, regarding the second question, it is asking whether there is an independency or relationship between 2 variables. The 2 variables are gender and program. The gender variable has how many levels? Yes, 2 levels. The program has how many levels? 3 levels. In either case, this or this, we can apply chi-square test. Like the case of a 고래밥 snake and the gender proportion, the first case, when there is only one variable and when we need to examine whether the observed frequency is statistically fitting or statistically different from the expected frequency, we can perform the chi-square test. This chi-square test is called as chi-square test for goodness of fit or one sample chi-square test. On the other hand, like the case of a gender and degree program, we can have observed frequencies divided by the cross tabulation defined by two variables, gender and program. The chi-square test for independence is examining whether the variables are statistically independent or not. Therefore, we use the chi-square test for goodness of fit in order to explore the proportion of cases that fall into the various categories of a single variable and to compare these ratios, these proportions, with hypothesized values. So whether the number of males and females are fitting to the hypothesized values such as 1:1 or 1:2. Remember the different figures in a 고래밥's pack? Let's perform the chi-square test for goodness of fit test, whether we can statistically say that each figure is contained in an equal number. In the first table, the observed frequency of each figure is presented. Among the total number, there are 15 sharks, 16 whales, and 70 starfish, and so on. Then let's calculate the expected frequency. The total number, so the total frequency is 131, and there are 9 types of figure. Therefore, ideally, the frequency of each figure should have been 131 over 9, which is nearly 14.6. The chi-square value is calculated then in this way. You square the difference between observed frequency and expected frequency, and you divide this through the expected frequency. Then you add all, and then you will get the chi-square value. What if the expected frequency and observed frequency are all equal? If so, the chi-square value will be, yes, 0. Therefore, when the observed frequencies are similar to expected frequency, then the chi-square value will be smaller. Once we have calculated the chi-square value, then we consult the chi-square distribution in order to see what probability the calculated chi-square value would have. Let's examine this case, this 고래밥 snake case, using Excel and SPSS. In Excel, I prepared like this. So I have copied the observed frequency table and expected frequency table. And as I explained, the chi-square value is adding all of this one. So let's calculate this. The from observed frequency, we subtract expected frequency and we square this and we divide this through expected frequency. And we do like that, and we add all. So we obtained 7 as the chi-square value. And let's refer to the chi-square distribution, whether this value is too big to say that the differences are statistically big enough, or this 7 is small enough to say that the differences between observed frequency and expected frequencies we can ignore, right? So let's go to the chi-square distribution. And because we had 9 categories, so in this single chi-square test, we calculated the degree of freedom as the number of a category minus 1. So in this case, the degree of freedom is 8. And when the degree of freedom is 8, then the chi-square distribution appears in such a way. And in order to say that the observed frequency is statistically different from expected frequency at an alpha level of 0.05, we should have at least the chi-square value, so the chi-square value at least 15.51. Do you remember that we had only the 7? So our chi-square value is still belonging to here. So the difference is not statistically different. So based on our calculation, we can conclude that these frequencies are statistically equal to 1 to 1 to 1 to 1 to 1. So the Gorebab snack company doesn't need to fix their machine. All right, it's a good news for them. And let me show you how we work on this using SPSS. In SPSS, we need to create variable figure, and here when I put shark and so on, so number 2, whale, etc., and so on. So for and I should have added up to 9, right? Because we have 9 figures. So here we have how many was it? 15 shark and 16 whales. So let's go back to the SPS data. So 15 times of a shark, and 16 times of whale. You can do this until you reach to the entire number, which is 131, or often you do this kind of tedious work in using Excel. If you use Excel, you can easily and quickly generate the data. I created this function to generate 15 times of 1, 16 times of 2, and 17 times of 3, etc. So this is the formula which I applied, but there can be different ways to generate these data. Anyway, so let me copy my data and paste this here. Alright, so let's check whether it has been correctly copied. So Yes, I think it has been correctly copied. 131 frequencies, and yeah, and so on. Okay. Right. Analysis, non-parametric, chi-square test, and figure. The first option indicates when our expected ratio is 1 to 1 to 1 to 1, and you can select second option when your expected ratio has not 1 to 1 to 1 to 1, but like 1 to 2, 1 to 3. Okay, so in our case, you want to compare our ratios, our observed ratios, with expected ratio, which is 1 to 1 to 1 to 1, right? Okay, so the chi-square value is obtained 7, and degree of freedom is 8, and the probability value is 0.534. So with this frequency, observed frequency, the possibility to be same like this ratio is much bigger than the exceptional ratio, which is 0.05, right? So therefore, we can conclude that our observed frequency is not statistically different from the expected frequency. Therefore, the Gorebab snack company doesn't need to fix their machine. Okay, so far is my explanation and the practice with regard to the chi-square test for goodness of fit test, and in next video I will continue the chi-square test for independence. Thank you.